my presentation is titled Quirks from the Cloud, and basically it's a series of interesting stuff, interesting things that we encountered either at Cyscale, either while building other products, while managing the accounts for the students for the course that Julia mentioned. And right, so what to expect at the end of this presentation. My main purposes with this presentation is to help you consider or to know what to consider when choosing a cloud provider or a service from the cloud, of course. That also includes Kubernetes and all that cloud native ecosystem. Also, I want to emphasize that some things in the cloud, but not only, pretty much everything in this domain is usually harder than expected, than it seems. And also, I'm going to try to provide some tips for building on the cloud regarding security, scalability, cost optimization. Why not? That's also important. From my experience, the main concerns of people that are thinking about choosing the cloud are one, cost. The main issue is that they cannot predict it, and the second is security. There are lots of stuff, lots of things to configure, lots of ways to configure things also, and that seems to scare some people away. But well, in fact, that's what we're trying to build at Cyscale. But yeah, let's not digress. And also, it might contain some complaints of mine that I encountered, or my colleagues encountered while working with the cloud. And we'll also try to have some fun. Why not? Cool. So, as I said, the presentation is based on managing an AWS organization with 94 accounts for UBB. That's again the setup that we have for the cloud applications architecture course. Basically, each student gets his or her own AWS account, so they can create resources and not overlap with the resources of other students. And yeah, it's not that complex of a setup, but nonetheless something interesting. It uses AWS SSO. It uses, in fact, it's entirely written in Terraform. Maybe we'll talk about it near the end. Also, the previous project I worked on while I was working at MSG was basically building an API marketplace on Azure, and we used lots of services, cloud native, like functions, API management services, of course, blob storage services, and stuff like that, and lots of experiences from there. Also, in 2019, together with a few friends, we started a cashback platform, of course, running on the cloud, and we managed to run it for cheap using Firebase, of course. That's my go-to for side projects. And we also encountered some interesting things on that one. We also used GCP, then we switched to Linode for hosting. For hosting, we have an Elasticsearch service that that indexes tons of products from multiple online shops. I think it has nearly 13 million products or something like that, and the idea is that that our users can search through all those products. So yeah, some experiences with that, and of course, perhaps the main chunk of stories and expertise that I'm going to present is based on working at Cyscale, where we are building this cloud security and not only platform for managing AWS, Azure, GCP, Aliun, that's the Alibaba cloud official name. And also we provide integrations with Okta, as in we can tell you, okay, these are your Okta users, and they have access to these AWS services, for example. And of course, our experience is not only from the research that we conduct, but also from actually running the platform. And of course, we use Kubernetes on AKS, Azure Kubernetes Service. Cool. So let's, and of course, I always strive to and try to build and learn on the side. And I think most of you do, because I assume that's why you are here. So I think we all have something in common. Cool. The first thing that I want to emphasize and to explain is that in the cloud business, and not only, it's never just. If we take, for example, just use Helm. For those that don't know, Helm is this package manager for Kubernetes. Basically, you can use it to install various things like MySQL, for example, any other piece of software, or close to any other piece of software can be installed through Helm. You can also package your services. And yeah, it's never just do that, just use that service, just use Lambda, just use Helm in this case. Because no matter what we choose, it always has some implications. It always requires some additional effort from us. In this case, for Helm, we might have to decide, okay, do we go with an umbrella chart, or do we have separate charts for each application? The chart is the name of a package in Helm terminology. For example, at Cyscale, we started with an umbrella chart, but then we split the chart into separate charts, each one of our services having their own charts, and we saw some benefits. But that's not applicable to all cases. If your system has multiple services, but they all are very, very similar, then you might handle things or manage things more efficiently using an umbrella chart, because you can define similar charts much easier. Right, then you also might consider, you have to consider if you need the chart repo. That's where you store the actual Helm packages, let's say. We don't use one, for example, at least not for now. Also, when installing third-party charts, do you just Helm install? That would be the command to install a chart, for example, MySQL provided by Bitnami, for example. Bitnami, by the way, provides charts for most open source systems, MySQL, RabbitMQ, all the good stuff. And yeah, the simplest way would be to just type in the terminal Helm install and the name of the chart. But you can also add those dependencies, those packages, those charts to your umbrella chart, and that would be better because, well, you can version control that. You can store that in Git. You know what you have installed in your cluster, in your Kubernetes cluster. Moreover, you might already have an existing cluster, Kubernetes cluster, and you might want to start managing existing resources with Helm. In that case, you'd have to add some labels to your existing resources so that Helm knows that or becomes aware of those resources. Again, something that you have to consider. Then again, you have to consider CRDs. Those are custom resource definitions, or rather custom resources, because Helm, so it does provide some support for CRDs. A CRD is a way that in which we can provide custom resources. Maybe we have, for example, we use Nats at Cyscale. Nats is is a messaging system. So think of it like a queue for messages. Actually, it does pub sub and all the good stuff. And it has some CRDs, because you can define the queues in simple terms using Kubernetes resources. And that would be one example of a CRD. And you might want to include that in your Helm chart, in your Helm definition. Again, something that you have to consider. And furthermore, with Helm, you cannot update CRDs. Yeah, when you first install your chart, you can add the CRDs, but you cannot update them after. And that was a conscious decision from the Helm team, because they tried to prevent breaking changes, and it makes sense. But again, it's something that you have to take into account. And yeah, you will sooner or later need to learn Go, at least some parts of Golang, the Go language, because of course Helm and Kubernetes and pretty much everything related is written in Go, including the templates. So when you write a Helm chart, you define some templates basically, and you can define string interpolation and various pipes. So you can change strings, uppercase, lowercase, provide default values, stuff like that, and all of those end up being processed by as Go templates. And if you have a complex enough setup, you will end up having to understand at least the Go templates. And also, since all this ecosystem is moving so fast, there are tons of resources regarding Helm, for example, that are basically outdated. In this case, I wrote here that they reference Tiller. Tiller is something from version 2 of Helm, which is no longer used today. So yeah, and some of them are the best resources actually. So blog articles and guides and stuff like that. Yeah. So the idea of this slide is that try to draw parallels between what you already know and the new services or the new tools that you think about using. So in the case of Helm, you could maybe compare it to NPM, the Node Package Manager, or Maven. Of course, the mileage may vary, but that would be something helpful. So again, it's never just. In this case, just use Helm would be something like just make more money or just stop being fat. But yeah, it's not that simple. In fact, I think that provides more insights than just use Helm. All right, moving on to the next slide, which is about regions. So this is about the different ways providers present their regions. You see, in AWS, for example, the regions are this overarching thing that you have to choose when you log into the console. That's the dropdown for regions for the regions, by the way. And everything that you do, or almost everything that you do, happens within a region. And if you switch regions, you are in a different cloud actually. On the other side, Azure, for example, this is the Azure portal. Doesn't have any region picker, doesn't have anything about that. Of course, you still choose regions when you deploy a VM, when you deploy some other resource. You do choose the region in which you'll deploy that. But it's not that that prevalent, let's say. And something interesting about regions, or some of the considerations that you should think about when choosing the regions. Well, of course, the first one is not on this slide, and it would be the proximity to your users, of course. But you should also consider the cost, because it varies between regions for all providers. For example, in the case of AWS, at some point, Sao Paulo, which is a region from South America, was almost 2 times more expensive than North Virginia, another region from AWS. Of course, there are multiple factors that impact the pricing. Probably taxes being the main factor here. And also, if you deploy in multiple regions, you should consider that the traffic between them, if you have some data synchronization, for example, is going to incur costs. All right, another consideration regarding regions would be feature availability. So if we take an example, Lambda. So at some point, AWS introduced Lambda, the functions as a service. And they made it available, or they first launched it publicly available in 14th of January 2015. So that's when it became available in EU West 1. That would be the region in Europe that usually gets new features earliest. Well, overall, the first region that gets, or at least so far, that got all the features, the first was North Virginia, but also Ireland in Europe tends to get new features pretty early. And the next, or if we take a look at Frankfurt, for example, it took 425 days until Lambda became available in that region, and another 449 days until it became available in Sao Paulo. So yeah, if you just use the old but gold services, EC2 and load balancers, and you're happy with that, that might not be that important to you. But if you are always trying to improve your infrastructure, improve your systems, use the new services, then that might be an important consideration. All right, and some resources. If we let's see if we manage to. I wanted to show you. So they have some nice representations. Let's see. I cannot see that's what I wanted to show you. So for example, this is the web application, after all, that Azure has, in which they try to show off their global infrastructure. And you can click around and navigate through it and see the regions. They have this naming convention that let's see if we look in Europe. Yeah, so the light blue, I think that color has a name, but nonetheless, that would be regions. They also show you wind farms and solar panel, farms. So pretty useful. All right, there is also one for AWS, of course. I think that, in fact, that's created by a third party. Yeah, so that's what it looks like. All right, going back to our presentation. Also, what I forgot to mention about regions. Some people might care a lot about the environment, about green energy, and that's good. And for example, Google Cloud makes it a big thing for them. And in fact, they show you next to, so when you choose a region, they'll show you, okay, this region is low CO2, so low emissions. So yeah, you might also consider that. Good. Moving on to resource groups. I just want to mention that, well, they are amazing. The resource groups on Azure, they are totally amazing. The fact that you can just, create some resources that you want to play with or research, and then just delete the resource group, which will delete all the resources in it, is incredible. And not only that, you can also use them for managing IAM permissions. So you can grant permissions at the resource group level, and automatically all the resources from that resource group inherit the permissions. In fact, that's how we manage permissions for Cyscale. We have a resource group for production, or only some people have some permissions on it, while the other security groups are for development, for the development environment, or created by some of us. So the interesting mention about resource groups in Azure is that when you create a resource group, you choose a region for that resource group. However, when you create a resource in that resource group, a VM, for example, you can choose another region, a different region than the resource group, and you end up with a resource group having or containing resources that might be in other regions. So yeah, some, or at least as far as I remember, when you try to create a resource, the default region that's set is based on the resource group. But yeah, nonetheless, you can choose another one. Cool. And you can also use them for security, for compliance, for again, for grouping infrastructure together. They also provide a nice way to visualize the resources in a resource group. So there will be a tab in the Azure portal that you can click, and you'll see basically a graph of your resources from that resource group. Also, another mention is that, well, we also have resource group in AWS, but they are not that powerful. They are not, in fact, they're not even equivalent, only to a certain extent. In fact, they're a feature of Systems Manager, SSM. And this is what you use if you want to apply patches, for example, to a set of resources, to a set of VMs, for example. So yeah, cool. Then moving on to encryption. First of all, encryption. So this is about encryption at rest and in the cloud. There is also encryption in transit. So that's those would be TLS, SSL, the good stuff. And also we can talk about encryption for the data in use. That would be confidential computing. Yeah, well, that's what I wrote my bachelor thesis on. At that time, Intel SGX was launched, and SGX is this mechanism to create encrypted memory. Well, they call them enclaves. And the idea is that your data is never unencrypted, or rather, your data is decrypted only within the bounds of that enclave, and only certain code can work with that memory. For example, if you want to create an online voting system for presidential elections. Probably you might find that useful, but besides that, it's hard to argue their use. But going back to our encryption at rest, well, first of all, encryption at rest really protects us from someone physically accessing our data. So someone somehow manages to break into the AWS or Azure data center, manages to find the drive that stores our data, and also manages to run away with it, which is a pretty big accomplishment. But yeah, it's still required for compliance. If you want to be compliant with ISO or pretty much any major compliance standard, you will need it. And in fact, most providers don't even provide a way to have unencrypted data. In Azure, in GCP, you cannot have unencrypted disks or not encrypted disks. You can still have that on AWS. So there are two things that I want to emphasize regarding encryption at rest. First of all, is that encryption is transparent. So the idea is that anyone that has access to an EC2 instance, in our case, can read the data that sits on an encrypted disk that's attached to that VM. So yeah, it might not protect you from attackers or something like that. Of course, intransit encryption does protect you from man-in-the-middle attacks and stuff like that. But yeah, and the other point would be that when using, for example, encryption with object storage, for example, if we pick S3, so when we work with S3, we can encrypt the objects that are stored on a bucket with a customer managed key. So that's a key that's usually managed by the key management service, KMS service from AWS. And basically, S3 will know to use that key to encrypt our data. And the important mention here is that it's not enough to have access to the objects, to the data. You also need access to the actual key. Those are separate permissions that the user needs to have. So even if you decide to make the bucket public, so anyone over the internet can access that bucket, you still need, or the person that tries to read the data would still need permissions for the encryption key. And also a fun fact is that some providers allow you to make encryption keys public for some reason. AWS, for example, allows you to do that. All right, moving on. Encryption. So since we talked about encryption, maybe it's worth to talk a bit about some of the options that we have, for example, with S3, because chances are you will encounter them. And well, there are three options. The first one would be the default S3 encryption. That's the original way to encrypt data on S3. It doesn't incur any additional cost, no additional permissions. You just enable it, and that's it. Then we have encryption. So SSE stands for server-side encryption. So server-side encryption with KMS, leveraging the key management service from AWS. And there are two ways to work with that. The first way would be to make use of this AWS managed key. So that's the encryption key that gets created the first time during the first time that we try to encrypt something for S3 using KMS. Or we can create our own encryption key, so a CMK, customer managed key, and we can reference that and tell S3, hey, please use this KMS key when you encrypt and decrypt data. And again, you need separate permissions for that. It does incur additional costs. However, it does provide better audit. So you know whenever someone decrypts or encrypts the data. And also, if you want to allow access from other accounts to some data stored in an S3 bucket of a certain account, then in that case, you'd need to use a CMK as opposed to using the AWS managed key, so the AWS/S3 key. That's just the default name that the AWS managed key gets when AWS creates it. Right, and the third option would be using customer encryption, or it's not customer, but client-side encryption. And the idea is that you have to provide the key in the headers of the request. So whenever you upload a file or read a file, you have to provide the key, the encryption key, in the request, in the header of the request. The mention here is that you will no longer be able to just paste in the browser the URL of an object and see it or download it, because again, you have to provide the header, the encryption key. And as a fun fact, on AWS, on S3, you can set the so-called default encryption. However, that doesn't really guarantee anything. It just says that, okay, if I don't specify the encryption type, then S3 is going to use that encryption method. All right, and if you want to actually enforce a certain encryption, you have to make use of the bucket policy, and there will be a condition that you have to add in there saying that, okay, I'm going to accept this request with an object, to store an object, for example, only if it contains the encryption key header, for example. All right. We don't have that much time left, so I'm going to go pretty fast. Maybe I'm going to skip something. Also, another interesting fact is that you can achieve certain things only through the CLI or the SDK. Of course, the CLI is based on the SDK, so pretty much everything that you can accomplish using the CLI, you can also accomplish using the SDK. And one of them would be, remember that we can make, in some cases, encryption keys public, so anyone can access those encryption keys. Well, we can also achieve that on GCP. Of course, please don't, but as a fun fact, you can do that, but only through the CLI. That's something we discovered like 2 weeks ago, because the web interface, so the GCP console, doesn't allow you to do that. However, the CLI does. Cool. Then another thing that we can accomplish only through the CLI or the SDK is assuming a role on AWS. So AWS has this concept of roles. Basically, when a user or a system wants to change their permissions, they have this option of assuming a role. Of course, they would have to have the permissions to assume that specific role, but in some cases, that role might be defined with an external ID. So that's a way to enforce trust, let's say. And you cannot assume that role from the AWS console, so from the AWS web interface, if the role has an external ID. There is no way to specify that external ID, because otherwise, if there is no external ID, you can just click around and switch role and type in the name of the role and also the account ID in case the role is in a different AWS account. But yeah, of course, this external ID feature is intended for integrations with third parties. For example, this is what Cyscale uses when it scans, or rather reads the the infrastructure of our customers. Basically, there is a role defined in the AWS account with a certain external ID that we also store in our database. And well, the platform simply assumes that role and starts reading the infrastructure because that role provides the permissions to do that. Right. Another interesting fact is that so in Azure there are these custom roles. Of course, there are the out-of-the-box roles, contributor, owner, roles specific to each service. But there is also the option to define custom roles. And well, if you try to do that from the portal, it's going to require you to have P1 or P2. That's a more expensive license for Azure Active Directory. However, if you do that from Terraform, or at least that's how we do it, it works, even if you have a free AAD license. All right. Speaking of things that you just, or rather don't just achieve it, we had some we gathered some experiences or some knowledge regarding service meshes, because at some point we decided, okay, we need a service mesh because we want MTLS between our services and all the good stuff. And of course, we tried Istio and Linkerd. Those would be the most popular options. We settled for Istio. What I want to mention is that, well, we faced several challenges. We thought that, okay, we're just gonna Helm install Istio, or rather Istio-CTL. That would be the Istio CLI. Install something, and everything is secure after that. Of course, it didn't work like that. However, if you have a very simple system, your experience might be just that. Just install it and you're good to go. However, we faced some challenges. So we have, for example, we have quite a few pods. So the pod is the box that contains your service together with some other containers along it. And the idea with most service meshes is that that pod in which your application is running will contain one more container. Besides your application or service, there will also be a proxy. In this case, the Istio proxy. And that's called the sidecar. And one of the issues that we faced was that the sidecars have or come with their own requests, come with their own requirements for CPU and for memory. And if you have many pods, adding that or those default requirements to your already existing requirements can require you to have a pretty beefy cluster. So we ended up just lowering those requirements. Also, so we tried switching to strict MTLS. Basically, there are multiple ways to have this MTLS setup. There's strict, there's permissive. And if we want to switch to strict, meaning that all the traffic within our cluster happens only through MTLS, we would have to get rid of our migrations, which are currently running as init containers. So that's a feature from Kubernetes. Basically, that feature is when Kubernetes starts your service, it will first run this init container, which can do anything. But a good use case for them is database migrations. So it's going to run that, and then it's going to actually run your service. However, they don't seem to work with strict MTLS. That's because MTLS is set up by the sidecar, which might or might not run before the init container. And yeah, you run into some limitations. All right, we have 11 more minutes. That's not much.
Yes, and Andrei, I would like to ask you to keep some minutes for the questions, because we have some questions already in the chat. So wrapping it up a little bit, and then we are going to do the Q&A.
All right. So I'm just going to talk for 2 more minutes, and then we can go through the questions. Regarding managed Kubernetes. So again, Cyscale runs on Azure, on AKS. Some of the things that we saw is that, first of all, you cannot skip versions when you upgrade a cluster. You have to go through each minor version, minor being 21, 22, 23, and so on. That's because all the providers have this highly available control planes, and that's a limitation of them. Cool. Also, when you upgrade the cluster, consider that you also have to upgrade all the things that run on it. In our case, we also have to run Istio and the Ingress Nginx controller. And some of them might bring breaking changes. We faced that, for example, like 1 month ago. Basically, they renamed the health probe path, though, so they added the Z. However, our infrastructure was not aware of that, and nothing was working. That's a change in the Nginx controller. Cool. Also consider pod disruption budgets. It's all in the Azure documentation, for example. That's a pretty cool feature from AKS, and it works. And in fact, that's how we realized that, okay, we have a pod disruption budget issue. Basically, this page told us that, hey, please check that. Cool. Some other considerations for managed Kubernetes. I'm gonna just leave that if you want to scan through them. All right. One cool thing about it is that, I mean, it's, it has pros and cons, is that all those managed Kubernetes offerings have good integrations with their IAM service and their KMS service. So if you want to manage secrets, for example, you can integrate the Key Vault on Azure within your cluster. Cool. We are going to skip this, even though it was a fun experience. Also, when you receive some credits from AWS in this case, please ensure that they are applicable to the service that you are using. So we forgot some database running. We contacted AWS, hoping that, okay, maybe they might be able to, help us with that. And they did, but they provided some credits for EC2. Our additional cost was for RDS. So the credits didn't help that much. But of course, they helped us fix everything in the end. Cool. Also, there are tons of load balancers, and it can be a bit confusing. In fact, Azure has even a service that helps you choose a load balancing solution. Pretty nice. And yeah, I also wanted to talk about security groups. We no longer have time about that, or for that. The idea is that they are similar but different on each provider. All right. AWS single sign-on. It's now called IAM Identity Center, and interestingly enough, it has almost nothing to do with AWS IAM, the other service for users. And also, it has a bunch of APIs that you can use, and it can be quite confusing because there are multiple APIs. So yeah. that would be it. Thank you, and of course, feel free to contact me on any of those email addresses. If you are interested about cloud security, and if you like, researching stuff, feel free to contact us. We're looking for cloud security architects or researchers to, help us improve the Cyscale security knowledge graph. And also, if you need a security solution, contact us. Yeah, so that would be
Thank you. Thank you, Andrei. We will continue in English if you started in English, and you have a round of applauses now. Thank you for your presentation. We already have some questions from Gabriel and Paul. Paul, let's go through the questions. I would suggest to go with Gabriel. And
sure.
yeah.
So do you prefer me asking the question in English, or do you want it in Romanian? I don't know.
Yeah, let's stick to English.
Okay, so regarding the external IDs and roles, what happens if you update the role in your account with a new permission? Will the customer have to update the role in their account as well?
What happens if you update the role with a new permission? So there are the permissions that the role grants, and there are the permissions that you need to assume that role. They are entirely different. So it's maybe I don't understand the question, but the customer will not have to do anything.
Okay, so the update to the role essentially propagates to all the customers. It should be transparent to them. Okay, cool. The other question of Gabriel was, should we keep all the services for an application in a single region?
All the services for an application in a single region. Well, the only good answer is it depends. And that's the only safe answer. Of course, you might consider going multi-region if you have users from multiple regions. Also, if you have, you can choose this multi-region setup as a disaster recovery option. And of course, there are multiple ways to have your backup infrastructure ready. You might have a hot standby in which all the infrastructure is ready in the secondary region, or you might have a pilot light approach in which you have only the core resources running in the secondary region, and when the disaster happens, you switch to the other region. So yeah, I hope that answers the question.
Paul just wanted to say that we have a raised hand from Petru. Petru, yeah, do you have a question? Can you write it down, or use your mic?
It might be that Petru maybe mistook
okay.
The raised hand to applause emotion or something.
Yeah, okay, just checking that we have that resolved. Okay, so mistake.
Okay, cool. So another question was, what do you think about Firebase versus Amplify? This was really at the beginning.
So I'm a big Firebase fan. I've also tried Amplify.
Amplify is a bit newer, so
yeah,
a bit more recent.
It is. In some sense, it's more powerful. They also provide this GraphQL interface or integration. What the thing I don't like about Amplify, or at least I didn't when I tried it, is that it's really big. I mean, Firebase also is quite big, so they add a lot to your bundle, to your web application bundle.
Okay.
Yeah.
Okay, makes sense. Makes sense. Thank you, Andrei, for answering our questions. It was a really interesting talk.
Thank you, Andrei. Thank you, everyone. Mulțumim frumos, Andrei.